operated and owned by NEP. And we happen to have their general manager, Barry Katz, here this evening. Thank you. I cannot recommend highly enough contacting Barry if you need production, post-production, studios, and God knows what else. They're a huge worldwide conglomerate these days. I worked here when I was a youngster long ago, and they're still going strong. So thank you very much, Barry. Thank you. In addition, I would like to thank our students this evening who are helping us do production using Wirecast that was provided, by the way, by Telestream. Thank you. And we have students from City Tech and from Kingsborough Community College, and we have John Acosta from the faculty lead from Kingsbury Community College. As you know, we continue to have a very significant effort with our student sections and subsections. Alrighty. Next, I would like to thank our sponsors. On the screen behind me, you see the Friends of SMPTE-NY sponsors. And as you know, they sustain us and make it possible for us to operate this section. And our sustaining sponsor is B&H Photo. They have made quite a bit of our operation possible this year. And all of these other fine organizations are here. But I would encourage you, if you don't see your company's logo here, to contact Tom Morrow, who is now in charge of this program, Friends of SMPTE-NY. Thank you. All righty. Next, a few more announcements. First of all, elections are taking place right now, section elections. That is for the New York section, for the Connecticut subsection, and for the Long Island subsection. And that happens online, and it goes until April 24th. So if you're a member and you haven't voted, please do so at your earliest convenience. In addition, I noted when I was looking at the registration for this afternoon, speaking of members and non-members, that there are 40 people here today registered who are not members. So you know what you need to do. Okay. Just go to that website, SMPTE.org, and sign up. All right. Next announcement is that, and by the way, when I was thanking the folks from NEP, I failed to thank Betty DeCares, who made all the arrangements possible for us, and I should have mentioned her by name. She did a great job, and she's been working with us for weeks. Thank you, Betty. All righty, so let's see. I did want to mention that we're getting toward that time of year where we'll be soliciting ideas for next year's, meaning next season starting in September, for programs like this. So if you have ideas, now would be a good time to start sending them in, either to myself or to any other member of the Board of Managers. We're going to start putting those together and vetting them. We decide on the program for next year by pretty much the end of June, and line them all up from September until the following June. So think about programs if you have interest. Okay, and now, without further, I'm going to toss for a moment to John Furter. John is our New York governor, and he's going to make some announcements regarding SMPTE business, and then I shall be back to introduce this evening's program.
Jeff, thank you, and thanks everybody. Thanks for your support of the Society. I just wanted to report briefly, in February, coincident with the HPA Tech Retreat in California, which was very successful, very well attended. We had our first of 3 Board of Governors meetings, which included a strategy day prior to that conference. And we on the Board of Governors, along with the Executive Board, are developing new strategies to move the Society into the 21st century. Many of what we're trying to do also is to enhance membership, so I'm very glad Jeff brought it up. It was brought to our attention that there are actually more life members, and to be a life member you have to be 65 years old and a member of the Society for 30 years. There are more life members than there are members under 30 years old. So we're going to do our very best, and Bruce Fulmer is very active in getting student members and getting those members to become regular members when they graduate and get into the industry. But we're also looking at the strategies, educational strategies, and our strategies on standards. And one of the initiatives that we discussed was expanding the standards group to involve a standards and practice group, so that instead of having these standards and recommended practices and engineering guidelines, which all have to be vetted and voted on and ratified, these would be workflows and work strategies that would be worked on by users and manufacturers and then put out as guidelines for new post-production and production workflows. So, so we certainly welcome, any suggestions. Doug Scheer and I are both your governors. Our next board meeting is in June, so I'm always soliciting ideas. If there are things that you have a concern that you'd like us to bring before the executive board, please let me know. And then if you have any other questions about the society itself, please reach out to us. Thank you.
Okay, so we'll dispense with the slides. And if you just douse the projector for a moment. Alrighty, so I'm going to introduce this evening's program, Metadata Tagging for Video for Fun and Profit, whichever, make your choice, fun or profit. I'm very pleased to have my close friend and colleague, Josef Marc, with us. Josef is the new CEO of a company called ViewStart. It's a small Norwegian software company. You probably have not yet heard of, but they're going to make a big splash in the US starting now. He's been a longtime SMPTE member and the author of 4 technical papers that have been delivered at the SMPTE annual conferences in the past. He's a member in 2 active SMPTE standards efforts, the IMF 35PM50 and the HDR Dynamic Metadata 2094. He conceived of tonight's panel at my request, and in his own words, those SMPTE projects are all about metadata tagging video for fun and profit. Josef will be joined by Tom Pflaum, who is the Director of Solutions and Technical Sales at Telestream. He has 20 years experience developing software products and designing solutions for graphics and media applications. At Telestream, Tom is responsible for working with customers in the media, telecommunications, and enterprise industries to design and implement solutions using Telestream's products. Tom holds a Master's in Mathematics from the University of Waterloo, Canada, and a Master's in Computer Science from the University of Erlangen in Germany. Fabio Schiattarelli, I hope I got that right, is an IT architect with over 16 years of experience in the media and entertainment industry. In this capacity, he has been responsible for designing and building media solutions that acquire, manage, store, distribute, and monetize digital video. He has implemented projects for several studios and broadcasters. Currently, Fabio is working in a global role, advising customers worldwide on digital video solutions that leverage IBM cloud and cognitive technologies to enrich metadata and personalize the viewing experience. And of course, this is referred to as IBM Watson. And then finally, we're joined by Ville Hulkko. Ville is the co-founder of a company called Valossa. They are a video artificial company, which is sort of like an AI video company, that was recently selected by Goldman Sachs as the AI as a service company to watch in 2017 among Google, Facebook, and IBM, and also Amazon and Microsoft. He works in close collaboration with broadcasters, content studios, and video platforms, and we'll be talking about Metadata 2.0. He joins us from Finland, so we're very happy to have him. Actually, Josef came from just a few days ago from Norway, and now we have Ville from Finland, so we have a really great international speaking group this evening. So without further, I'm going to introduce, let Josef take over, and they will present, and then at the end we'll have questions. Okay.
Okay, first slide, please. As Jeff mentioned, you haven't heard of ViewStart yet, and that's because it's a...
Details.
Yeah.
You're going to run your own slides. They're
Okay.
gonna follow you. I'm sorry. So just follow this on your slides. Put your here. So start your review.
That's a video, and that one, ViewStart.
So just go
Mhm.
full screen. Just use your arrows.
Yep, okay. Yeah, ViewStart is, well, I'm a longtime SMPTE member, as Jeff mentioned. And whenever possible, whenever I'm in New York, I like to come to chapter meetings here. I love this chapter. And I especially love this chapter's focus on young people. As John mentioned, that's an important focus for us, and Bill Miller, I believe, is here, and he's my hero. So when I think about tagging video for fun and profit, I'm thinking about the next generation, and often what do they think that SMPTE, how is that relevant to what they're doing today? Because if you think about it, SMPTE 12M was SMPTE timecode. It was the original meta tag for video, the timecode reference, and it served us very well. So now we're going into the next generation of what that can mean. So I was a bit surprised when I heard from a small Norwegian software company, and I looked into what they were doing, and I realized, yes, of course, that's exactly what they should be doing. So the company, ViewStart, is small, but their partner is not small. The if you don't recognize the name Magento, it's a software platform for e-commerce. So if you go to L'Oreal or the New York Times or one of those sites and start any kind of commercial relationship with that website, you're using Magento technology. That gets programmed, of course, by software developers, what I sometimes call Java jockeys, forgive me, even though there may be no Java involved, or not even JavaScript sometimes. But it's just because it looks different to my generation, right? What we did with BNCs and wires and large CAD drawings, they're now doing with software development. So this group is the partner. And I want to show you a video that was in production before Jeff and I started putting this together. And its audience is general. I'm learning Jeff's trackpad. Okay. So I asked the ViewStart video editors to make this language independent, since ViewStart is now going to leave Norway. There's a little bit of English there, but most of it doesn't require knowing English. And the concept there is what we're going to talk about today, what you just saw. So we can come back to that video if it helps us. And this drawing. There, I've learned Jeff's trackpad pretty well, haven't I? All right, so this drawing is normally meant to explain to people sort of a little bit of what's under the hood at ViewStart. But notice what's missing. Those online services. ViewStart does not make the online services, and that's why we have my fellow panelists here to explain that. So I just want to say that from the perspective of the users, of ViewStart's users, which are merchants at this point, bloggers, even an outdoor festival, a music festival, they use it for many, many different things. So we can't talk about what is the use case of ViewStart. There really isn't one. It's just what people think it is tags in the video. And you saw all those objects that were highlighted in the video and then at the end, the store concept. That's a real thing. Although all those tags were made by employees of the store. And that's what doesn't scale very well. And you saw that video of a fashion week. At a fashion week, there's a lot of cameras. It goes on for a week, and there's a lot of video. So it's not really practical to put most of that video to good use if you have to do all the tagging with human hands. And so their goal is not to put people out of work. On the contrary, they want to use their people to do things much, much better because the people know stuff. So those people need help from the computers. So we want the computers to do what they're good at, and that's what we're going to talk about, what the computers are good at, and then bring it back to the ViewStart platform where the people can put it to the uses that they want to use it for. So we're going to go, I just want to orient you to a couple things on this slide because we're going to go to another slide next. So you see that the owner's computers is where the video starts. In fact, a lot of that video starts in live events like Fashion Week. A lot of that video starts at a manufacturer, like L'Oreal would have videos made by the manufacturer of different brands within their enterprise. They go to a video library that ViewStart uses one on Amazon right now. Works great. And then we build the ViewStart instances, also in Amazon virtual machines. We send the video to online services, and this is where it's just getting exciting. This is sort of what my job is now as CEO, is to get that really going and make that really practical. And then those services return JSON and other data that we call meta tags, and we use that to tag the video. We present that back to the merchant in a UI so that they can have some control of what they do with that information. So any questions about how that works? Good. I was hoping it'd be pretty simple. That's what this one's for. Okay. So shall we move right on into the nuts and bolts of how those tags get made? What actually happens in the sausage factory? Okay. Fabio, please. Now you have to learn the trackpad.
I need to press the ask button and
yeah. It's on the desktop.
click that.
It's a hard trackpad.
There you go.
You really got to.
Good evening, everyone. And as Josef was saying, we're getting into the nuts and bolts. And the question that we want to answer tonight is, can we use a machine to do the work that loggers for years have been doing? So extracting metadata out of content so that this content can more easily be searchable, reachable, usable. And the answer is yes, we're getting there. It's difficult to define what state-of-the-art means today because things are really moving quickly. I'll take one approach here that is like describing what IBM has put together its offering as a product today. And we offer this as service, which means that these are the little building blocks that can be used to assemble more complex and extensive solutions. So your company can use it and another company can use it. Like for a couple of examples. Company here in New York, without making names, is using it to get metadata out of content to create recommendations for online content access. Company in France is using it to do speech-to-text translation and text-to-speech so that content can be automatically dubbed into a different language. And I'm sure you'll come up with more examples in a few minutes. So I'll briefly go through the single building blocks that we offer on the market today in the cloud. And we call them cognitive service. And we'll get to the meaning of the word cognitive in a minute. But let me go through the list. Visual recognition. I mean, all of this are, you're probably fairly familiar. What we do in visual recognition, we're working with images today. So when you're working with motion video, to some extent, you still have to extract some keyframes out of content and apply them to the visual recognition component. But you can get some information. So if there are people in the image, you can get like number of people, the gender, the approximate age. If there are celebrities, the system will automatically recognize out of the box. It will also automatically recognize the context in which they are. If they are indoor, outdoor, if it is a party, if it is a cityscape and countryside, et cetera, et cetera. In addition, you can customize the system by building what we call classifiers. And you can train the system to recognize other individuals that may not be the celebrities that the system recognizes out of the box. And we'll get to how to train the system and what it takes in a minute. Then we have ability to recognize tone, emotion, and sentiment analysis. At this point, as a product, we do this out of text. So what we normally do is either you start from a script of your scripted content, or you do speech to text, extract the text, you put this in again, a computer application that will identify the tone and the sentiment. And the way we characterize this is like sentiment is the emotion that the person is having while they're speaking. The tone is how that emotions gets perceived by the listener. Keep in mind this is used in a wide variety of cases, so it can be applied to video content. It can also be applied to phone conversation and people discussing with an agent. So this is fairly general. Concept extraction and entity extraction, again, they work today out of text. And what they do is they identify key concept in what the user is talking about. So if I'm talking about geography, like my travel, then it will identify this as being like geographical places, etc. The point is that it can infer the concept, not necessarily from the words. So it's not just like keywords extraction and counting the keywords. There is a level of intelligence and an inference in extracting those. And then entity identifies key people, geographical places, company, et cetera, that are being mentioned. Speech to text, no need to explain that. And language detection, at this point, working on a limited number of languages, like about 8, allows to submit some video content, extract the speech out of it, and do identify the language. Again, state of the art is rapidly changing. Tone emotion analysis is working on words today. We're starting to look at like using facial expression and the voice tone to get the emotion out of that. The visual recognition is rapidly shifting towards using video as a primary data type instead of using still images extracting for video. The concept extraction is getting more and more sophisticated. A quick word about what we mean by cognitive. So some of these technologies have been around for a long time, right? Like scene change detection, speech to text, concept extraction have been there for like, in some cases, like 10, 15 years or more. So what makes a system cognitive is like a number of things. The ability to understand. So the ability to, first of all, process unstructured information as video, images, and plain text can be. And understanding them the same way that humans do. Like understanding, inferring the meaning that's behind the words or the video or the actions. They have the ability to reason. Let me get rid of this. So again, grasp concepts that are not immediately present in the information that's being processed. And more than anything else, they are able to learn. So in the old days, building a system that had these capabilities required a lot of effort in teaching by humans to put in the rules and the processes, et cetera, that were needed for the system to understand and process the information. That is somewhat going away. So the system has, through its understanding and reasoning capability, the ability to be initially trained, and then as the system is working on data and humans are validating the results of what the system is creating, then the system learns and gets better and better at what they're doing. And that's a key element because it cuts to a fraction the effort that's needed for the system to perform these tasks, for this system to perform this task. So as I was mentioning, these are the building blocks. So the question is, how do you put it all together to implement the supply chain that would work in our everyday working context? And this is my attempt to put all what it takes to do that. And at the center of that, you see the extract metadata. So this is where you see the little building blocks that I was talking about until a minute ago. What else is needed? So first step, you access and transform media, right? So to feed still images into the visual recognition, or to feed speech to text into the tool, or to extract the closed caption track out of your video content, then some type of traditional transcoding video processing transformation is required. And we don't only work on the video and the scripts and the audio, we also work on existing metadata that exists out there. One of the things we do very often is we apply tone analysis on the synopsis of a movie that's on IMDb or Rovi or your favorite source of metadata, because that will give you the same kind of tonal information, et cetera, that you can get a lot easier than other ways. The next step is creating the content breakdown structure. So you apply these techniques at various levels of aggregation, right? So you start with let's say, episodic content, a 21-minute episode of something, and you want to extract as much metadata as possible out of it. How do you do that? Well, one thing you can do is apply these techniques, the tone analysis, the concept extraction to portion of it. You can, or in some case, you do this into its entirety. It really relates to what information and what detail you want to extract. And so one thing that you do is you break it into scenes. Like 21-minute episode typically may contain what, 10, 20 scenes? And then you break farther down the scenes in 2 moments. A moment can be like a 1, 2, 3 second section of that movie, and all the way down to a single frame. And then once you have done this decomposition, then you can apply these various techniques of analyzing the tone of the conversation, the discussion, the characters that are in there, and on and on and on. And by the way, this breaking things down into scenes can also be done using the same cognitive techniques. So in the old days, this was the traditional scene change detection, right? You analyze frame by frame. Whenever the frame was changing rapidly, well, there was a scene change. Well, that's not simple, because if you're having an interview, then your angle changes continuously between the interviewer and the interviewee, but that's still the same scene. So applying cognitive techniques allows you to do better things than our traditional techniques. And once again, you have extracted these techniques, and I'll go back to that in a minute to give you a practical example. Then you want to put this metadata, all this worth of metadata you have extracted, and potentially when you're working at single frame levels or like 1-2 second moments within a 30, 60, 2-hour video, long video, that's a lot of data. So you want to categorize that information in that structure. So you're building a hierarchical tree of information where all this information is managed and aggregated at a proper level within the structure. And then you want to browse, edit, view this metadata, you want to search on this. So that's the next step. The last one is you may want to look at this video information that you have collected at a very granular level and start combining it together and do the reverse process. This is probably where this technology is going to, and it's the leading edge. And our challenge, where we think we want to go with this, is as I'm analyzing something, and by way of example, I see men and women, and they walk into the scene, and they get close, and they talk to each other, and the tone of the conversation is romantic. Can I define and tag that line as a love scene? Because that gets into where potentially a lot of the value in this is, not just search, but essentially evaluate content and define content so I can build recommendation for people. That's one of the many use cases. We can have many other, and we could spend a whole another session discussing the use cases. So again, just connecting all these pieces together, this is how the logical flows goes through. And what you see at the moment is, well, you have a level of process orchestration, and we have people in this room that make the living working on orchestrating video processes, but that's a key element. So all of these elements need to be coordinated to get to your final result. One key element is some of this takes training and design, and I'm going to spend a few minutes around this. So obviously, this is a process, so you need to build workflows and rules around that. A lot of this is about training this. So like the scene decomposition cognitive has to be trained. The various annotators, the one that allow you, for example, to recognize a character in a show, have to be trained. So the system, as I was saying, comes with out of the box, but some of this needs to be, if your character is not out of the box, then you need to train the system. The way we do it today is we give the system a number of pictures of that character, 50 as a minimum, positive, like 50 picture of that guy, and 50 picture of someone who looks like that guy but who's not really that guy. So 50 positive, 50 negative. That's what we consider the minimum for visual recognition to work effectively on someone. And it gets better as the more images you provide. Once you get about like between 100 and 200 images at that point, you are not going to get much better by results. Similarly, we train some of these speech to text. Like when you're working with some episodic content, what you typically we've seen doing is like we train the system to recognize the visual recognition to recognize the 10, 20 key characters. So once we have done that, then the system will automatically be able to characterize each scene and pull the characters that are present in each scene. If there are certain specific words that are specific, like words and locations and places and names and people, especially in science fiction, that are unique to that content, then we train the system to learn and understand this content. We train the system, for example, to understand tennis. Took us like a couple of days to train the system so that they would understand like the terminology of tennis, how words are related together, what words are used in connection with other words at that point. At that point, the system was able to tag tennis games and be pretty good at that. And again, then you build models and the aggregation rule. I just want to wrap up, because I'm thinking I'm being long, with a practical example. This is something that we built to put all these things together. And so we put video through the process. We did this at 3 levels. We did this at the full video level. We did this at the scene level, and you'll see like how up here how the scenes were divided based on that criteria. And then we did that at the moment level, where a moment was a frame captured every 2 seconds. And depending on the context, we were applying some of these techniques. For example, we were doing the transcript at the scene level and the moment level. We were doing taxonomy analysis at the scene level. We were doing visual recognition at the moment level and identifying characters, color, objects, etc. Note how on the right side you can reverse the project. You can use that same information to query the system for scenes. So in this case, you can tell the visual recognition, like, find me all the scenes where there is like this character or this celebrity, and give me all the scenes where like joy is the permanent emotion. And again, the system will just do that. In this case, for example, I'm just showing you how in this like presidential inauguration scene, the system detected the key emotions, and everything comes back with a probability range, right? This is like not a perfect science, and so it will find that conscientiousness and agreeableness were the key emotion that were perceived by the system, and there was a wide emotional range. So again, my objective here was just to give you a bird's eye view of the technology. This is not a good example. For those of you that are coming to NAB, and I'm sure there'll be quite a few of you, then we'll be glad to give you a live demo. Thank you.
I'm actually going to have some questions for you a little later. But before Tom gets started, I just want to make sure something was clear from my slide, if you don't mind, Tom. Just the recent. So what you're saying then is that chunking process, that whole orchestration, kind of starts in my example at the view start machinery, right? And then it proceeds to yours where so some of that we can do ourselves, and some we can offload to you, and there's a line there to be discovered. Is that right? Is that fair?
Yeah, I mean, you can, again, there is no clear delimitation. It's all of this has to be done with some technology versus another. The point is, those are all building blocks. So there is the flexibility of combining them together in many different ways. In some context, it makes sense to chunk the content in smaller pieces. If you're doing news content which has like 2-3 minutes typical duration, it may make less sense. Right. You can use various techniques to do that. I mean, you can use your scene break detection techniques of choice. I mean, we can provide one which we think it's good because of their cognitive analysis, but there are several on the market that will work on fade-ins, fade-outs, etc. So okay. Pick your choice.
So I want to use that as a segue to Tom and Telestream, because you in this audience, you're pretty familiar with his technology, and I just want to show that some of the differences here that we have opportunities to think about in the coming year as we start to use these services.
All right, thank you. All right. All right. I'm going to be talking about how to use metadata in video production workflows, orchestration of the file production and transcoding and similar processes. So just to introduce myself, I'm Tom Pflaum. I'm the director, as was mentioned earlier, of pre-sales and solutions at Telestream. We also have Bob Barnshaw here from Telestream. If there's any more questions, he's somewhere there. Okay, just a quick overview. I'm going to be talking about metadata and the growing importance of metadata in file-based video production workflows, in the orchestration that you were talking about that has to happen, how important metadata gets and how it becomes more and more important, and in particular how it becomes more important as you talk about new distribution platforms. As you put your content, for example, on video-on-demand systems, all of a sudden you need the guide data, you need the author. If you send your data to social media platforms, more metadata is required. It's not just like linear television where you have your TV guide and that's all the information that really is needed and the video would just play back to back. I will close going to the initial thing. Are you doing it for fun or why are you doing metadata? There's one more reason, because you have to. So I'm going to talk about closed captioning. And it's the right thing to do, but there is legislation that will tell you that you have to provide closed captioning, and we will provide a tie-in on how we can use AI as a service to actually facilitate and simplify the production of closed captioning. Okay, quickly about Telestream. Telestream, as you said, we've been around for a while, since 1999, and we have been probably best known for transcoding, but since then we've gone beyond that, and the appearance of metadata is one of the reasons why we're now talking about a media processing platform that needs to deal with media, that needs to deal with metadata, that needs to talk about QC features, that needs to talk about captions, that needs to be able to work in all these environments, and of course, everybody needs to do something in the cloud now. So let me talk about metadata types that generally appear in video production workflows. There are file headers, like the information. If you've got a video file, there's a header. The header contains information, very technical, typical. You have the frame rate, the duration, is it interlaced, is it progressive, what kind of file is it? So this is really just metadata that you have actually in the header for you to pick up and utilize. However, there are also file characteristics. That is also metadata that comes into it. For example, what is the loudness of the audio? What is the frame structure of the video? And you have to gain that information by actually looking at the video, analyzing the video. There is, I call it descriptive metadata here. This is what we talked about earlier. Basically, in metadata that tells you something about the actual video. Not technical information, but actual information. Who are the actors, right? What is the synopsis of the program? That type of information. There are the captions. Talked about that. You probably are familiar with the 608, 708 captions. There's actually a lot more that you have right now. And there's other types of metadata as well that you typically find in the VANC data, which are used for things like dynamic ad insertion. You need to know where the ads are supposed to go, what type of ad you expect here. Is it a local ad? Is it a national ad? So metadata becomes very important throughout the entire process to actually, in this new infrastructure of over-the-top video and video-on-demand systems. So this is just reiterating where are the where's the metadata coming from. Talked about the file header. QC applications can provide it. Hey, what's the loudness? Hey, what's the brightness? Is there too much flashing video in there and it might cause epilepsy? It's a test that's required in the UK, for example. There can be sidecar files, XML files that get delivered with the media that contain metadata that you have to process, that you have to use. There are API calls, web service calls and calls in the cloud that can provide you additional information. I'll talk about the Associated Press's new tagging service briefly as one of these examples. There's, of course, always the manual entry. If you don't have it, if you need it, if you have a smart system, maybe you don't have to manually enter it, but manual entry, you probably can't avoid it completely. There's always something, if something is missing, a person needs to enter that information. And there are the closed captioning source files, SCC files, things like that. Okay, so, and here again, so how can we access these metadata? I kind of mentioned that earlier. Basically, all web services, sidecar files. So let me give you Some example. The first one is something that's labeled smart transcoding here. And what this is doing, this is basically investigating the source file, making decisions, and based on those decisions, it will trigger the way the video is encoded. This particular workflow here is basically videos coming in. It could be 16:9, it could be it could be HD, it could be SD, it could be letterboxed, it could be curtained. What I want is a proxy that I'll generate of that video that has the right aspect ratio and does not have bars, either on the side or on the top. And to do that, first I investigate, I check the header. Is it HD, is it SD? What's the raster size of it? Then as a second step, I'll basically analyze the video and figure out, are there black bars? Where are they? How big are they? And based on that, I'll trigger the creation of the proxy. So this is one thing where you extract metadata from the header as well as from the actual video content. Here's another example. It's not always, as I mentioned, about transcoding. Sometimes you just basically look at the media files that are coming in that contain information. I'm not going to be doing anything with the video file. I'm just going to be publishing that information. And that could be simple stuff like the duration. That could be simple stuff like I'm extracting the captions out of it and publish that. Doesn't need to be complex, but this I might be able to, I might want to publish that to the asset management system, whatever system sits around it. I mentioned earlier, one other way is there is a service out there that provides me with additional metadata. The Associated Press provided a service that in addition to delivering, I think a lot of people here will know what the Associated Press does for broadcasters. It provides kind of raw clips or raw news footage. Like they have tons of reporters, video reporters in the world. There's a video file. That video file, if you subscribe to them, gets delivered. Used to get delivered with very little information, the slug information that comes with it. Now they offer an extended service that has its own taxonomy and labeling that comes with the video file. Now you're getting the news story. You don't have to watch the whole thing anymore to know what it's about. You have got some kind of idea. Who are the people that appear in it? Is it relevant, right? So the way you can work with that in an automated, orchestrated platform workflow is, in this case, I'm assuming there's an XML file that gets delivered in conjunction with the video file. So we're using this function here called associate. We basically have a file that gets associated with the video file. That metadata gets transformed, the video gets transcoded, and then it gets deployed, copied wherever it needs to be, into an asset management system, onto a publishing platform, whatever the right thing is. Okay, so these are sort of just some examples of metadata that are being used. The next one I want to talk about is captioning or subtitling. That is sort of one of the probably most important things that came up, that have been around for a long time in the US. There was a requirement to put closed captioning into broadcast video, probably since the 70s, something like that. But recently, a couple of things have changed on that. One thing is now also the online content that you put on over-the-top services that you put on the websites needs to be closed captioned. Okay, that's still easy enough. You just basically put that on there. But now there are also quality requirements for the closed captioning. So for example, a live event gets usually closed captioned by somebody typing away, typically court reporter on a stenographer's keyboard. Of course, on a live event, the closed captions is going to lag behind the video. It's just impossible. Somebody needs to, you cannot type it before it's being said. So that needs to be done. And it used to be that for the on-demand versions or rebroadcasts of that was good enough. You could just use the same captions. That is no longer the case. You need to have better captions than that. So there is a caption authoring step that's basically exploding. More and more captions need to be produced. Promos now need to be captioned in the US. If you go to other countries, they start adopting similar standards of requiring closed captioning of the actual content that is put not only on broadcast television, but also on social media sites, websites, sites like Netflix, YouTube, that kind of stuff. So I think I mentioned most of that. So I want to talk about one other thing. Closed captioning, subtitles, what's the difference? The difference is on the two that closed captioning is the US terminology that's been used for 608, 7OS, closed captions in the US. It is there, was developed for hearing impaired people. So when you look, so it's designed for people that can't actually understand the audio. So you will see things like a shot is fired and you will see bang in it. Subtitles was usually referred to as a subtitle for different language. However, outside of the US, it's generally referred to as subtitles. Okay, where does that leave us with all these new internet delivery formats that you have out there? Well, somewhere in between. Because, I mean, it used to be NTSC content 5997 had closed captions, PAL content 50i had DVB subtitles in the transport stream. Now you put that into onto a website. Well, could be either 25 frames per second, 60 frames per second, doesn't really matter. You can play it either way. So one terminology that appeared is called time text. I just wanted to explain that because I will use that going forward. Time text is basically both. So when you look at the web formats, there's something called web VTT or SMPTE time text. So time text is just a terminology that's being used to get, it's a new word, but it sort of solves a little bit of the confusion that existed between closed captioning and subtitles. Okay. As I mentioned, the standards are getting stricter and stricter. And what are the challenges of providing closed captioning? Well, it involves a lot of different groups within a video production organization. You have the captioner, court reporter, or somebody who just authors the caption. You have the video editor. The video editor might be before, might be after, might be somewhere in the middle. There is a problem here. When do you actually do the captions? Because you need the captions when you air it. So you can't do it at the last minute, or it will delay airing of the content. Now you have them both. Then it comes down to the engineer, let's say broadcast engineer, or the one that creates the video on demand content. That needs to make sure that both things are available in the right format at the right time, and merge them both together. So what is even worse is that in the world of closed captioning, there's a big challenge, or time text, I should say. There's a big challenge of like lots and lots and lots of formats that are out there, formats that are constantly changing still. So they have not settled down. There's just a lot of formats that you have to deal with on that. So you need some kind of a system that turns one format into another. You kind of need to transcode captions just like you transcode video, just because there's so many flavors out there. And you know, the social media platforms just all adopted a whole new standard based on SMPTE time text, but nonetheless. Also, these video formats that you have, like MXF files, they also can contain captions. So somehow these captions need to make it into these file formats. So again, you need an orchestration system to actually do that. So now let me get a little bit more into how do I actually author these captions. And that's, I want to close the loop here, going back to AI as a service here. The traditional way of authoring captioning is typically you start for, not live. Live, I mentioned you have to type. But if it's a produced show, you start with a transcript. Sometimes, if it's a person talking at a prompter, that transcript might just exist. There's nothing you have to do. But typically it does not. So somebody needs to type that. Then the next step is there are certain regulations of how many words per minute you can actually have on the closed captioning. You cannot just kind of fire words at people. Nobody can read it. So there are regulations and standards on how many words per second you can actually have. So that needs to be adjusted. Then you need to format the captions. You want to put them on the screen somewhere where they don't cover something up that's important. Typically, you've got a lower third running a crawl at the bottom. You don't want the caption smack on top of it because you won't be able to see it. Sports, you don't want it on top of the score ticker, which happens a lot. Once I've done that, then you need to actually align the captions. I've got a transcript. That's got no time code. It's just a transcript of what was done. Now it needs to be aligned with the actual audio being spoken. After that, I now have a file that I need to export and feed into the rest of the production process. So, funny thing happened. This is a screenshot of one of our products called Caption Maker, and we started because we are selling these caption products to caption all our company videos, all the promotional stuff that you find on our website. So it came to a surprise to us when talking to the guys in the marketing and girls in the marketing department that the way they captioned was actually kind of funny. They didn't just write down a transcript. Actually, what they did, they took the video, uploaded it to YouTube. YouTube has an auto transcription service, so that gave them a transcript, not necessarily very good, but they have one, and they use that as a starting point to go through the other steps that I have on the screen here. So after we made that observation, we actually kind of figured, well, maybe we should probably look at integrating one of these kind of services that you were talking about into the product and make it a little bit easier, help a little bit, even if it's not quite perfect yet, but make it a little bit easier to capture the content. And as I said, there will be more and more and more need for closed captioned subtitled content. So this one here is, for example, it's just an example for social media. Again, you need another type of formats. If you go to Twitter, do you have to subtitle that? No. Should you? It probably makes you look better if you have that option. All right. So to come to a conclusion, the points I was trying to get across. The new digital and over-the-top video formats, publishing platforms require more metadata. It's just intrinsic. There's guides, there is web pages that they're embedded in, that you just need more metadata. The caption and type text legislation is out there, and you are required to caption content. So that's another big use of metadata. And the other thing I wanted to make here, point I wanted to make is that after all of this and all the formats I listed, metadata is complicated. And captions and metadata in a lot of places is an afterthought. And that is not the right way. There's too much that can go wrong. Many times do you get some type of metadata, and it's just not quite formatted right. So it can't be used within the system. And in order to use it for that, you need a certain level of automation around it to not have all manual steps to make the metadata, embed the metadata into the video, and things like that. So thank you very much.
Thank you, Tom.
Yep, you're welcome.
Ville, while you want to get your computer set up, I'm a longtime SMPTE member, and I learned some things today. I thought I knew all about this. I've actually worked on standards and products, so I didn't know all of it. I want to show you something, and it really got me thinking, about my current position at ViewStart. Here's what I'd like to challenge. I haven't met Ville before today, so we don't know each other. Nice to meet you. But here's what I told the ViewStart board of directors when they first met me. This is a television. This is my television. And around my house, we've got about 20 of these. They're all different sizes. One of them's stuck to the wall, and it's pretty big. But they're all televisions. And we use them personally. Occasionally, we show them to each other. Sometimes we'll sit together and watch one of these televisions. But they're all televisions, and in my mind. And every time I touch this television with my finger, it's got a fingerprint sensor, this one does. Not all of them do, but this one does. I want to see video. I don't want to scroll my TV. I don't want to read my TV. I can talk to this thing. I can shake it. It already knows where I am and what I'm doing. So why isn't this video? Why?
Thank you. And ladies and gentlemen, it's a pleasure to be here. Thank you so much, Josef, for having me. My name is Ville Hulkko. I come originally from Finland, from the cold, cold north. And I'm one of the co-founders of a video artificial intelligence company called Valossa. One of the things that we discussed with Josef prior to starting this is how did we originally actually get started with the company before we reached the point of 2017. Now, as this is 2017, the year of artificial intelligence, for us who are following the news, we know that AI is now everywhere and it's emerging. But actually, when we dive into the history of different AI platforms and the history of it, it's not a new thing. Computer vision has been around for decades, and the latest wave started a little less than 10 years ago. So did we. When we were starting off the company, a lot of the different research groups around artificial intelligence were focusing on being the best at a vertical, being the best image tagging company, being the best at recognizing zebras from hockey referees or different kinds of image tagging. But we sort of wanted to follow a bit of a different philosophy. What we felt is, as individuals, as humans, we don't focus on a single data feed to perceive the world. We have 5 major streams of sources, our 5 senses. Now, as we are a video artificial intelligence company and working with the same data, we also wanted to bring this approach into the video AI space. So what we built was the first, what we call multimodal artificial intelligence platform. And our goal was to aggregate as many different sources of data into a single feed of understanding. 7 years later, our research group of 9 people now grew into a startup of 9 people. And now multimodal platforms are in existence by IBM, 3 weeks ago by Google, and by us, Valossa. I don't have a PowerPoint deck with me, but I just figured the best way to do this and the best way to demonstrate what we want to do with video artificial intelligence and meta tagging in the practical sense is by demonstrating it. So I'll show you a couple of things to get this kicked off. First, I'll show a practical output of what multimodal AI work looks like. Let's see if we'll get this going. Hello, dear friends at McKinsey. I'm doing a live demonstration about some of the AI detection or artificial intelligence can do to, for example, a cell phone video. Hello, it's good to meet you. Hello, Rebecca. Unfortunately, that's not from New York, nor is it from Finland, it's from California. But what we did here is I shot a video with my cell phone and I fed it to the artificial intelligence. It started off by recognizing me as a unique individual based on the structure of my face. It categorized the video based on some of the auditory content and some of the visual content that it perceived and gave it a category that it believes it belongs to. In this case, it has something to do with hobbies and interests or about transportation and computing. It recognized me as a man. It perceived a vehicle, wood. Going into more detail, a bicycle, a road bicycle, a table, my glasses, my facial hair, a surfboard, and some vegetation. So many different kinds of categories inside it. But what it also did is listen through my dialogue, what I was explaining in the video, and understood that I'm discussing about artificial intelligence detection, about a live demonstration. It picked up the name Rebecca, the name of an organization, McKinsey. And all these results, all the data that you see here is made by the AI, so there has been no human handiwork in between. Now, what this means in practice is that, as we discussed before, we're able to use a computerized system into creating these kinds of visual taggings from within the content. But that's sort of one side of the coin, correct? Another side of the analysis that I'd like to show you is what we do for the analysis of the human. Let's see if it works with these slides, but so this is me. This is a webcam feed. It's quantifying some of the facial expressions that are happening in the live video feed. I can teach it my identity. So I'll tell it that it's me. Now when I go away, I come back. There it is. And the number that you see next to my face, once it loads up, is an approximation of my heartbeat at this moment, once it remains stable. As you can see, doing a live demonstration does its tricks. Now, why is this relevant? Going back to the world of cognitive systems, it's all about learning, teaching, making the machine become more human and more understanding and more self-refining. The way that we can do that is take a number of data sets, take a number of images and throw it at them, make them learn new things. But the other way we can approach that is by giving feedback, by giving actual quantified signals to the system which works and which doesn't. Now imagine if we could reach a point where as we consume content, the engine that is giving us the content is also be able to learn how we react to the content, if we find it positive, if we find it negative, if it's appropriate to us. And not just generally, not just if Ville likes Game of Thrones or not, but within each single second inside the content. When the guy gets his head cut off, is it appropriate for me or is it not? Now, Samsung got a bit of a slap on the wrist a few months ago for a bit of a misplay when they announced, or not announced, but it was derived from their terms and conditions that they listen to everything that you discuss in your living room. That's maybe not something that we want to do. But through survey group studying, through agreeable observation of the consumers at this point, we can reach a completely new level of content generation. Because this is not just video this approach of tagging is applicable to. It's applicable also to the way that we consume, for example, comic books via iPads, via computer games, via cross-content referencing. Now the output of this AI, why we're here today, is what we hope to build into what we call Metadata 2.0. We got a lovely description just now to all the different kinds of metadata types that are currently in existence and in production. And most of them say, for example, or other than the time code within a subtitulation, are uniquely descriptive to each pieces of assets. The next generation of this is metadata that's uniquely descriptive to every single frame of a content, to every single second inside of a content. Now the question then becomes, how do we turn this tagging into this usable metadata? How do we standardize the format? How do we build it into asset management systems? And this is the challenge of the broadcasting industry in 2017, in my opinion, in our opinion at Valossa. And what we're doing as a company right now is collaborating closely with different research groups as well as different companies working in the industry, trying to start this discussion about the standardization of this kind of metadata 2.0 or scene-level time-coded metadata. And as we are all broadcasting engineers here in the room tonight, I would like to maybe, after the panel and everything, hear your opinions about how we, the engineers building this platform, could give suggestions to the companies and the research groups who start implementing these standards about how we practical players see this data should be structured. And I'd love to hear a discussion about this after the panel. But I guess that's my 2 cents for the introduction of the AI platform. Thank you.
Well, this is SMPTE, we're a standards body, so yeah, let's get into that. And now that you've heard all these, forgive me if I play that video one more time, because I'm going to play it without the sound this time, because I want to talk over it. Jeff, I almost love your trackpad, but not really. Okay. And video. Okay, and somewhere's a mute. Okay, so what Ville just said about we can tag every frame, that's what ViewStart wants to do. That's exactly what we want to do. We want to tag every frame, and for various purposes. And as you can see, when this comes to the fashion week and then the interior shopping scene, obviously that's a commercial purpose. But that same tagging, we're going to use it for many, many things, right? So we have no choice. We just have to go ahead and build a elastic searchable JSON database. That's all we can do right now, right? And we're going to have to fix it later, right? So so just imagine all of this data and there's some about every single scene and every sound. In this case, it's happy robot music, but in many cases, there's going to be ambient sound, there's going to be recorded sound, there's going to be words, there's going to be many languages, right? That's sort of the point of View Start. This has to work everywhere. And changing this part of the video, it's pretty easy for everyone to read English, right, around the world. Not everywhere, but many places it's generally acceptable, right? But when you say that's a television, well, and then it gets a little more complicated than that. Having the robots replace that with Asian characters and other Cyrillic characters and so on, that's not too difficult, right? Tom, you can fix that for me, right? Okay. Right. So I'm assuming the best there. And I can tag all this to a time reference, to milliseconds, based on a start time of a video. So I can do some chunking on my own. I can do some of that pre-processing on my own. But I'm still just making a huge pile of JSON, right? And I know this is going to end in tears eventually. So does anybody here have a better idea? Anybody? Well, so Tom, why don't you tell us since you are in the transcoding business, the transforming business, what can we do about this? What are the core problems?
I think what you get as far as metadata, especially when it comes to more descriptive type of data, it is very hard to have any type of standardized format or taxonomy or something where you know what it actually is that you're getting, right? The problem with that is once it gets down, we basically get involved once there is a standard, and once that mapping happened, then we usually integrate that with the other media types, the video files that are part of it. But before that, unless there's some clear structure of it, it is really hard to actually do something with to process it right now. So I think you're dead on that there needs to be some type of, and a subset would be perfectly sufficient. If you would say like, hey, let's focus on detecting objects, I don't know, right? And just classify those, have those in a standardized format. I think that might be a good approach of just taking that kind of approach versus trying to do just everything we could possibly find, trying to turn this into a structure. That will probably take a while for that to settle.
Okay. Just to give my 2 cents to the question about how can we approach this, the problem about killing the JSON dump, if you will, is that right now, most of the researchers are living in the mindset of more is more, correct? We want to be able to recognize more things visually. We want to have a million instead of 100,000 recognizable objects, which then get dumped into a JSON, which is essentially useless. The question then becomes, in my opinion, about a proper taxonomy and the proper hierarchical structuring about all of this data that we're able to then extract. Because a word in itself is useless unless it's bound to some other form of context, which would be that a dog is a mammal, but dog is also a pet, a friend, a companion of a human. A dog simplifies or signifies love, these kinds of different hierarchical associations. And this is something that's now a turnkey, in my opinion, to the first commercial solutions in broadcasting to these kinds of artificial intelligence tagging solutions.
So to add to that, so I completely agree on taxonomy. So we have spoken a lot tonight about knowledge extraction. There is a whole other discipline around knowledge engineering that describes, okay, how I'm going to represent and model the entities and the concept that I'm extracting. The other tools, I briefly mentioned about those, like a hierarchical representation, so you're going to break down your content into logical. So video, which we all deal with, has this time representation, so that strongly drives the approach that we use to represent the knowledge that we have about that. And hierarchical representation, breaking down in smaller chunks, is a key element of that. Canonical metadata structure. As we work in the industry, I think, as in many cases, it is of the essence that we have a common way of representing the information that we are extracting. So there is interoperability between content that you may be created, but I may be using, or someone else may be consuming, etc. So that is of the essence. Let me offer another perspective, because that comes from one of our customers. As we were one large broadcast company here in New York, as we were having these discussions, and we were saying, okay, we're going to extract all this metadata, and we're going to build an enriched metadata repository. And they came back to say, no, we're going to put all the metadata in one place. So we're going to take your enriched metadata and add the existing metadata and put all of that in one place, because we cannot afford to have multiple repositories just now because you're creating all this new trove of information. It has all to be in one place so that it's searchable and referenceable all together.
So what did you do? I mean, did you have to?
Eventually, yes. Eventually, the strategy was to import information, existing metadata, generate the enriched, enhanced metadata, and put all this information in a single searchable structure as the solution for this.
Okay, so you took the existing data structure, added to it, and then returned it.
Yeah, and in many cases, the challenge is that the MAM systems that we have in place today are not necessarily equipped to manage effectively all this richness of information, and we can now extract from content automatically.
So in ViewStart's case, you can see that since we don't have any of these services, and we have to be able to use all of them, right, as they come up in business, are we going to get ourselves into a hole we can't get out of? Are we going to be, I can do that with you. I can say, here's the data, enrich it, and give it back. But can I do the same with you? And he's already said he can't transcode it until I give him a taxonomy in the first place, right? So is it then on me to make a taxonomy, or is it on me to deal with all the services independently and then bring you in to fix it? I mean, what does this mean to ViewStart? Sorry for being selfish, but I'm honestly confused.
So my opinion would be, one way to tackle that would be to basically come up with a use case, focus on the use case, and provide the information for the use case. I mean, I talked a lot about subtitling. That's might not a very complex one, but it's still an important one. But that's very clear, timed data of what is being spoken. I mean, it's probably a tiny, tiny, tiny subset of what it is, but there is a real problem there, and if you've got more information, you can improve on it. Like, you recognize the face of a person, so you correct the spelling of the word or something like that, right? That can still be helpful, but then the data that gets actually handed down is targeted at a particular application, just as an idea.
So you're saying start with the use case and tackle it that way?
Start with a use case. Oh, yeah. I mean, yeah. Mm-hmm.
What do you think?
Absolutely. Starting with the use case in this case is essential. And what we need to remember here and what we need to recognize is that as we are now entering sort of a new age of metadata, if you will, what's also happening is that we're also getting a new generation of entrepreneurs and companies. Because before it used to be us, the toolkit providers. We make the engine which churns out the metadata and, your problem, right? Now the toolkits are available. You can go and you can tap into, Google's APIs or IBM's APIs or Valossa's APIs, and you can build your own applications. And you don't have to be a PhD of data science, computer vision, artificial intelligence, or natural language processing in order to do this. All you need to do is able to use an API and understand an industry. So it's a very interesting time that we're now facing, and I'm very much looking forward to the first next gen, if you will.
One.
Yes, I'll bring the mic down for questions so everyone can hear you.
I had a question about tagging visual information. Is there like an 80-20 rule or a 10-90 rule where 10% of the items you try to identify are really hard and 90% are really easy? Is that kind of equation occur?
You have the engines. What do you think?
Probably in a specific industry that may be true, or rather, if it's a question about the difficulty of tagging it, I don't want to give a scientist's answer, but it sort of becomes then a question about how do we want to recognize an item in a video. For example, if I take a water bottle and this is a camera and I point it at it like this, it's very easy to recognize. If I let it roll over the floor or put it far away and point the camera here, it becomes much more difficult to tag, even though it's the same object. So, there isn't really an easy answer to give to this, but it then becomes a question about how do we attune the models to respond to different angles and different kinds of use cases. And also, different industries have different visual representations that they want to focus on. For example, in professional broadcasting, stylistic elements are extremely important. In sports or rather automotive, not so much.
And in ViewStart's case, it's actually remarkably easy because before you even start working with ViewStart, you have a use case in mind, right? So in most cases, you're building a store, you know what you're trying to do, and the videos themselves are constrained within that use case. Yeah, I'll bring the mic.
One aspect about these APIs. So this APIs will not typically give you a yes or no answer. For most of these elements like visual recognition, emotion recognition, terms, etc., they will give you a probability, a confidence factor. Sometimes this factor is 99%, sometimes it's 60%. And then to enhance this, it's using the context to refine this information and aggregating various types of information to enhance the confidence factor will raise the level. And very often we use tricks. For example, we use this visual recognition technology in sports. When you're doing a soccer game, just because of my legacy, you only have 23 players, 23 people in the field. So your visual recognition is really restricted to those. That they will easily boost the capacity of the system to deliver a reliable recognition. In other cases, it's the responsibility of the system to decide this is accurate enough to make a good guess, or this is not determined.
And we have another question, but I also want to point out that, again, from ViewStart's perspective, good enough is actually good enough in every case, because there's still a business editorial process, right? The machines don't go live in our case. Yes, you have a question?
Yeah, so from a real 50,000-foot level, in looking at existing commercial off-the-shelf services, if you will, offered by Google, image recognition programs, Bing, Yandex, I could see a scenario in which I need in my efforts, in my work, where I have a still image and I then want to start searching video with that still image and get some hits. So are any of you trying to develop some sort of just basic, leverage models that you can at least start to gradually introduce people to the power of this?
Well, I'm going to hand this answer off, but I'm going to say from ViewStart's perspective first, that will be a byproduct of what we built. It's not intentional, but it turns out that it happens to work. And we're not going to commercialize that I know of. It just was a byproduct for us. So what do you think?
The searching of visual cues starts today, at least in the most generally used systems, from the meta tags themselves. So the way that the process is built is that you analyze the image, you create the meta tags, and then those meta tags become searchable. Theoretically, if you are able to, for example, take a frame from a movie, meta tag that, and then you analyze every single frame inside a movie that's, approximately in the same standards. You could do comparisons of those meta tags in the individual frame level and then make the connections. In practical sense, we haven't yet worked on this kind of an image matching solution. We did build a search engine that was a contextual search engine that actually outperformed every single video search engine on the market today on movies, including Google, yay. But that's a sort of a different story. Theoretically, everything starts from the meta tagging level, and if we have images that are close enough to each other, we can do the direct comparisons or make, like with the question about the thresholds, suggestions about what the AI perceives would be a close comparison to the image itself.
I have a question. So I think the majority of the people in this room are somehow connected to either to the television or the video industry. And it's a business model that lives on panaceas. The current panacea is, the IP workflow, but the one that we're currently living in right now is file-based workflows. And so what's touted is that file-based workflows are going to be a great advantage to the industry, and there'll be commonality. But what it does is it creates a monster in terms of transcoding and storage applications, so that this beast sort of comes from the ashes of all the advantages that these tool sets bring to the table. How much additional burden does this AI philosophy, this concept, this metadata that's available for a variety of different applications, what burdens does it place on a facility in terms of additional requirements that need to become part of their business model?
That's a good question, and it's going to be the last question for now because we're going to end the video soon. But thank you, because I have to pay for that storage.
I mean, this is hard to answer, and we can just basically look at the closed captioning and the amount of, just as an example, right? And there's probably more coming. So as far as storage goes, it's probably not all that bad, but as far as processing goes, there's a fair amount. You're basically creating multiple versions of it. Not of the big files, typically of the little ones that you use for distribution. That's why I'm saying the storage might not be the biggest problem, but the processing, of course, you need to read the files, you need to change the metadata in them, the captions in them, things like that. You need to do that many times for the different platforms. It certainly puts stress on the infrastructure that you have. How much, I don't know. That kind of depends how many platforms you publish to and things like that.
And so how we approach that is when the video comes to us, we take it apart, right down to its constituent elements immediately, and we send those off to the services. But my other fear is what happens when one of my customers' videos goes viral, because we're also paying for the streaming.
To answer the same question from another perspective, we do offer this building blocks I was talking about in the cloud. So that moves really the computational capacity in a different place that's not your infrastructure. But it also shifts the problem to a different issue, which is for the cloud to process that information and give me a reliable answer, then I need to transfer some information to the cloud to those building blocks. Today, that's not so much a big deal because we're working on single images, text information, audio extracted at not huge resolution. So we're not sending the 50 megabit per second XDCOM to the cloud for processing. We do extract a subset of information and we send that to the cloud for identification. That makes the problem a lot more feasible. So in this perspective, you're performing certain operations on your local infrastructure, like the extraction identifying the key information that's necessary for the cognitive services to operate, and then in the cloud you perform those actions. That makes the architecture a lot more scalable and reasonable in terms of performance and cost of implementation of a solution like this, because you don't have to set up a huge system to do that. You're using your existing infrastructure, and then you're delegating to cloud systems the new tasks.
Maybe just, for the question, my 2 cents would be that, in my opinion, the legacy cost of this starts from the quality of the data, right? As we're getting a huge, big data dump of data, it's better be correct. And currently today, don't crucify me on this in about 2 years' time, but we're sort of operating on an XY scale like this of scalability versus accuracy of that metadata. Scalability being the AI-generated metadata, and the accuracy being that data then refined and looked at by humans. So if we focus on the purely scalable solutions currently, then we might get some legacy costs later on if we need to clean up that data and make it more refined again. But I think, as always with artificial intelligence, the true golden line lies somewhere in the between of those two, especially when we're working with professional, high production value content where the data cannot afford to be wrong. But the good thing about artificial intelligence is that as it's learning all the time, the curve is shifting all the time toward the more scalable solution, up, if you will, to a Pareto efficient point. So hopefully these things will be just a win in the history in about 2-3 years' time.
And thank you for using Pareto efficiency in a sentence. Thank you. Thanks, Jeff.
Well, yes, Joseph, thank you very much, and to Tom and Ville and Fabio. A really great panel. I felt like I was at a TED Talk tonight. It was just terrific, thank you. And thank you for everyone who joined us. If you gentlemen would join us, we have a long tradition of taking a photo together as we give you some plaques to thank you for your participation. So if we can just take that photo up, and I'll get in the back here, and because I'm supposed to be in the middle. Yeah.
And you're tall.
I'm tall. And folks, everybody will be available, I guess, in the lobby if you want to keep chatting on the way out. We do have to be out of the studio by 8:30 tonight, so help us do that, if you will. Thank you. All right, so there we go. We're going to get everyone together. Okay, so your plaques, you will be getting a plaque after the fact. That's the dummy plaque. Great. So that's the image that will be in the Motion Imaging Journal. So folks, thank you so much. We'll be announcing the April meeting date. That is going to be a meeting that we're still working on planning. May, as you recall, is always the NAB wrap-up. June, we're going to dive into Aspen and Ames 2022-6 and other such wonderful IP standards. Thank you again for joining us. Good evening.